Hello students and good afternoon. So now I am doing class for class 12 science. The topic is invertible functions. Okay, so we will do some problems on invertible functions. So I think you have revised all the theorems that we did in invertible functions. So if you understand that invertible function, then it will be easier for you to solve all these problems now. So let's do this from exercise 2C, page number RF, that is relation and function chapter, that is page number is 48 from the book Senior Secondary School Mathematics for class 12 by R.S. Agarwal. So now let's start this question number 1. So question number 1 is, show that the function, you have to show that the function f such that R to R, that is real to real numbers, defined by f of x is equal to 2x plus 3 is invertible. You have to prove that this function of x, which is equal to 2x plus 3, is invertible, and hence you have to find out f inverse. So I think you have understood the question. So in order to show that the function is invertible, you have to show that it is 1-1 function. So we did the theorem, isn't it? If the function is 1-1 on 2, then the function is invertible. So let us show that this given function is 1-1 on 2, right? So let's first show that this function is 1-1. So here given function is, f such that real to real number defined by f of x is equal to 2x plus 3. So now first of all, let us show that this function is 1-1 function. Okay, so what is the method of showing 1-1 function? So f of x1 is equal to f of x2 should imply x1 is equal to x2. Let us prove it now. So we have f of x1 is equal to f of x2 for all x1 comma x2 belong to R, this domain R, right? So which implies that what is the value for f of x1? So you x को जगह में हामी के हाल्छौ x1 हाल्छौ. तो यो कति हुन्छ 2x1 plus 3. This is 2x1 plus 3 is equal to what is f of x2? It is 2x2 plus 3. Okay, from both the sides you can cancel this 3. So which implies that 2x1 is equal to 2x2, which implies that again 2 will be cancelled. So x1 is equal to x2. So now we have proved that since f of x1 is equal to f of x2 implies that x1 is equal to x2. So we proved that the given function f is 1-1. Therefore, the function f is 1-1. Therefore, the function f is 1-1. Okay. Now we have to prove that this function f is onto. So in order to prove onto, let us assume that y is equal to f of x is equal to 2x plus 3. Let y is equal to 2x plus 3. So let us get the value for x in terms of y. So which implies that 2x is equal to y minus 3, which implies that x is equal to y minus 3 by 2. Now, for every y belonging to this real number, this x belongs to this real number domain, isn't it? So let us write here, for each y belong to R, that is your codomain, there exists x is equal to y minus 3. There exists, this is the symbol of there exists, x is equal to y minus 3 by 2, that belongs to R, that is your domain, such that f of x is equal to f of, within bracket, what is x here? It is y minus 3 by 2. which is equal to, now what is the value for f of y minus 3? So instead of x, this instead of x you have to put y minus 3 by 2. So this becomes 2 into y minus 3 by 2, isn't it? 2 into y minus 3 by 2, then write down plus 3. Plus 3. Here 2 gets cancels, which is equal to, this is y minus 3 plus 3, 3 gets cancels, which is equal to y. Is that clear? That means for each y belonging to the codomain R, there exists x is equal to y minus 3 by 2 that belongs to the domain R, such that f of x is equal to y. Therefore, the function f is on 2. The function f is on 2. Therefore, the function f is on 2. Therefore, we have proved that the function f is 1, 1 on 2. Therefore, the function f is 1, 1 on 2. So the function f is invertible. Hence, the function f is invertible. Hence, the function f is invertible. So we have proved that the function f is invertible. Now we have to find out f inverse. Now what is to be calculated? You have to find out f inverse. You have to find out f inverse. Okay. So now again write down y is equal to 2x plus 3. Y is equal to 2x plus 3, or what is the value for 2x? So you can find out f inverse now. So 2x is equal to y minus 3, or what is the value for x? X is equal to y minus 3 divided by 2. Is that clear? So, or what is it? What is the value for x now? So actually y is equal to f of x. Actually y is equal to f of x. So what is x is equal to? That is your f inverse y. So this is f inverse y is equal to y minus 3 by 2. So we have got it, right? So therefore the answer is, so we can write down the answer as f inverse. This is the function f inverse, such that this is also real to real. This is also real to real, is defined as f inverse y is equal to y minus 3 by 2. So this is the answer for f inverse. So I think you have understood it. So you can copy it. So this is very, very important question. You may get the question like this in your HS examination. Okay. So you can practice it at home. So now we'll do the next question. So you can copy it. So now we'll do the next question, that is question number 2. Let the function f such that q to q is the set of rational numbers. So what do you mean by rational numbers? A number which can be written in the form p by q. A number which can be written in the form of p by q, where q not equal to 0 and p and q are prime to each other, is known as a rational number. A number of the form p by q is known as rational number where q not equal to 0 and p and q are prime to each other. What is meant by prime to each other? They should not have common factor in between p and q. So this type of number is known as what? Q, that is your rational numbers. Okay. So let us do this question now. Let f such that q to q, rational numbers to rational number, defined by f of x is equal to 3x plus 4. So that f is invertible. You have to prove that f is invertible. That means in this case also you have to show that the function f is 1, 1 on 2. Then only f is invertible. And hence you have to find out f inverse. So I think you have understood the question. So let us do the solution. Here given is f such that q to q defined by f of x is equal to 3x plus 4. Now you have to show that this function of x is 1 1 on 2. So first of all, let's show 1 1 function. Let us prove that f of x is 1 1 function. Okay, so for this, let x1 comma x2 belong to Q, that is your domain Q. Okay, so we have f of x1 is equal to f of x2, which implies that, so you have to get the value for f of x1 from here, put x1 instead of x. So what do we get? It is 3x1 plus 4 is equal to, what is f of x2? This is 3x2 plus 4, right? So here 4 gets cancels, which implies that 3x1 is equal to 3x2. Now again here 3 gets cancels, which implies that x1 is equal to x2. So I think you have understood it. So we shows that is we have proved if f of x1 is equal to f of x2, then x1 is equal to x2. This shows that the function f is 1 1. Therefore the function f is 1 1. F is 1 1. So I think you have understood it. Okay, now we will prove that the function f is onto. Let y belongs to this Q, that is your codomain. Let y belongs to Q, that is your codomain, second Q. Okay, so let us assume let y is equal to f of x is equal to 3x plus 4. So now let us express x in terms of y. So which implies that y is equal to 3x plus 4, right? Which implies that 3x is equal to y minus 4, which implies that x is equal to y minus 4 by 3. So we have got the value for x. Okay, now for each, now in this case, if y is a rational number, then x is equal to y minus 4 by 3 is also a rational number. Is that clear? If y belongs to the rational number, then x is equal to y minus 4 by 3 also belongs to the rational number, right? So for each y belongs to Q, then there exists x is equal to y minus 4 by 3, y minus 3 that belongs to the rational number Q, that is domain, such that f of x is equal to f of, within bracket, what is the value for x in this case? It is y minus 4 divided by 3. Y minus 4 divided by 3, which is equal to, now here f of x is equal to 3x plus 4 is there. So instead of x you have to write y minus 4 by 3, isn't it? So 3 into y minus 4 divided by 3. Is that correct? So 3 into, instead of x you put y minus 4 by 3. Is that right? Then plus 4. Then write down plus 4. Here 3 gets cancels. So which is equal to y minus 4 plus 4. That is here 4 gets cancels, which is equal to y. So in this case, for each y belongs to the rational number Q, then there exists x is equal to y minus 4 by 3 that belongs to Q rational number, such that f of x is equal to y. That means the function f is onto. Therefore the function f is onto. Therefore the function f is onto, right? So therefore the function f is 1 1 onto. Therefore the function f is 1 1 onto. So if the function f is 1 1 onto, then you can write down that f is invertible. So hence f is invertible. Hence f is invertible. So you have understood this first part, I think. So next you have to find out f inverse. So now again here you have to write, let y belongs to Q, that is your codomain. And again let y is equal to 3x plus 4, right? Or what is 3x is equal to? This is y minus 4. You have to again express x in terms of y, okay? So x is equal to, this is your y minus 4 divided by 3. So instead of x, what can you write? You know that y is equal to f of x. So when f goes to the left hand side, becomes f inverse y, right, which is equal to x. So instead of x you have to write f inverse y is equal to y minus 4 divided by 3. So this is f inverse, okay? So therefore f inverse such that rational number to rational number, and f inverse y is equal to y minus 4 divided by 3. So this is the value for f inverse. So we have got it. So I think I've understood it. This is same as problem number 1. Okay. So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 4. Let f, function f, such that this is the set of real numbers, but this real number does not contain minus 4 by 3. Okay, but this real number does not contain 4 by 3, or this set does not contain minus 4 by 3. R minus within second bracket minus 4 by 3 means your real numbers ma minus 4 by 3 चाहिँ छैन. ठीक छ, यो चाहिँ भयो डोमेन. 2 r minus 4 by 3, this is your codomain. यो codomain पनि set of real numbers हो, तर यो set मा फेरि के छैन, 4 by 3 नै छैन. And it is defined as f of x is equal to 4x divided by 3x plus 4. तो यो minus 4 by 3 यहाँ किन नभएको भन्दा फेरि यो चाहिँ x belongs to this real number. If you put x is equal to minus 4 by 3 here, 3 gets cancelled, minus 4 plus 4 is 0. That is, denominator is 0. If the denominator is 0, it is undefined. That's why it is written here r minus within second bracket minus 4 by 3. Is that clear? So find f inverse. You have to find out f inverse in this case. So in this case, you don't have to show that f is invertible in this case. So directly you can find f, you can find out f inverse. Okay. So here given is f of x is equal to 4x divided by 3x plus 4. So let us write it in terms of y. Okay. So let y is equal to 4x divided by 3x plus 4. Because you have to find out f inverse, isn't it? So let us assume this given function as y. Now let us express x in terms of y here. Now cross multiply. So 4x is equal to 3xy plus 4y. Okay. So now keep the terms containing x on the left hand side. 4x minus 3xy is equal to 4y. Okay. So here x is taken common within bracket. What do we get? 4 minus 3y is equal to 4y, right? Or what is the value for x here? X is equal to 4y divided by 4 minus 3y. That is here x is f inverse y, isn't it? So or this is your f inverse y is equal to, what is it? What is f inverse y is equal to? 4y divided by, it is 4y divided by 4 minus 3y. It is 4 minus 3y. So I think you have understood it. So this is the function f inverse. So therefore let us write down the answer. So f such that r minus within second bracket minus 4 by 3 to r minus within second bracket 4 by 3. So why is it given r minus 4 by 3 here? This y belongs to what? Codomain, isn't it? Here y belongs to this codomain r minus 4 by 3. Okay. Now in this case, if you put y is equal to 4 by 3, 3 gets cancels, 4 minus 4 is 0. That is 0 is undefined. So that's why this 4 by 3 is excluded. This 4 by 3 is excluded from this set of real numbers. Is that clear? So, which is defined as f inverse y is equal to 4y divided by 4 minus 3y. So, this is the answer. So, what is the value for f inverse? It is 4y divided by 4 minus 3y. Here, y belongs to the codomain r minus 4 by 3. So, I think you have understood it. So, you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 5. If f of x is equal to 4x plus 3 divided by 6x minus 4, and in this case it is given that x not equal to 2 by 3. So why is it given x not equal to 2 by 3? Because if you have x is equal to 2 by 3 here, 2 by 3 means 3 2 is 6, 2 2 is 4, 4 minus 4 is 0, that is denominator is 0. If denominator is 0, this f of x is undefined. That's why it is given x not equal to 2 by 3. For all x, but x not equal to 2 by 3. So in this case, all values of x are defined here except x is equal to 2 by 3. So x should not be equal to 2 by 3. You have to show that f of x, f of x is equal to x for all x not equal to 2 by 3. And hence you have to find out f inverse. Okay. So let us prove that. So that f of x is equal to x. Okay. So therefore f of x, let us find out its value, which is defined as f of x, which is equal to f of, what is f of x here? This one, 4x plus 3 divided by 6x minus 4, right? Again, which is equal to, now instead of x there is 4x plus 3 divided by 6x minus 4, होइन? x को जग्गामा के आयो? यो whole fraction आउँदैछ. 4x plus 3 divided by 6x minus 4. Now, instead of x, you have to put 4x plus 3 divided by 6x minus 4. So, what does it become now? Is equal to 4. Again, instead of x, there should be 4x plus 3 divided by 6x minus 4. Then plus 3. This whole divided by, again 6 into, this is 4x plus 3 divided by 6x minus 4, bracket closed, minus 4. Minus 4. So I think you have understood it. So instead of x here, we are substituting 4x plus 3 divided by 6x minus 4 on the right hand side. So we got this expression. Now let's simplify it. So which is equal to, what's the LCM in the numerator? So what's the LCM in the numerator? That is 6x minus 4 is the LCM. So now take the LCM and now simplify the numerator now. 4 4s are 16x. 4 4s are 16x plus 4 3s are 12. Right? Then plus 18x. This is your plus 18x. 3 6 are 18x. Minus plus minus 4 3s are 12. This is minus 12. Right? So similarly you can get the LCM in the denominator. That is also 6x minus 4. Now simplify it. 6 4s are 24x. 6 4s are 24x plus 6 3s are 18. Right? Then minus 4 into 6x minus 4. That is minus 24x. This is minus 24x. Minus into minus plus 16. Plus this is your 16. So I think you have understood it. So let us simplify it now. Here 6x minus 4 will be cancelled. Here 12 gets cancels. Here 24x gets cancels. Which is equal to, now what is 16x plus 18x? This is your 34x divided by, what is 18 plus 16? This is also 34. That is 34, 34 gets cancels, which is equal to x. So this is an identity function, isn't it? We have proved that f(f) of x is equal to x. So that is f(f) of x is equal to x, proved. That is for all x not equal to 2 by 3. So let us write here, for all x not equal to 2 by 3. So we have proved it. Okay. Now hence you have to find out f inverse. So you know that this x can be written in terms of identity function, okay, or f(f) of x is equal to I of x, that is identity function. So from both the sides it is just like cancelling x. So what do we get? f(f) is equal to I, right? So what does it indicate? So you know that f(of) is equal to I, f(f) is equal to I means, what is it? This is f inverse is equal to f. This indicates that f(of) is equal to I. f(of) is equal to I. What does it indicate? It indicates f inverse is equal to f. Just like you know that GOF, GOF, isn't it? GOF is equal to IA. If GOF is equal to IA, then what can you write? Z is equal to f inverse, or you may write f inverse is equal to Z, isn't it? Similarly here also, f(of) is equal to I. If f(of) is equal to I, then you can write down that f inverse is equal to f. So instead of f there is Z. There is Z, isn't it? So that means f inverse is equal to here, G is f here. Here what is Z? Z is f in this case, isn't it? Here G is f in this case. So G is equal to f is there. So f inverse is equal to G, but in this case f inverse is equal to f, because both are equal here. Both are f function, isn't it? So from the definition of invertible function, we know that if f is invertible, then there is a function g such that GOF is equal to IA. So we know this definition from invertible function, isn't it? If GOF is equal to IA, then G is equal to f inverse. Is that clear? Similarly here also, f is equal to f inverse, or f inverse is equal to f. So I think you have understood it. Okay. Next, which implies that f inverse is equal to, what is f here? F is this function, but you write it in terms of y. Okay. So in terms of y, what is it? For instead of x, you write y plus 3 divided by 6y minus 4. So is it understood now? So therefore f inverse y is equal to 4y plus 3 divided by 6y minus 4. Because in this case f inverse is equal to f. What is f actually? It is 4x plus 3 divided by 6x minus 4. So instead of x, you may write y. Okay. For all y not equal to, this is also the same case, that is 2 by 3. So this is the answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. Let A is equal to 2, 3, 4, 5. This is your set A, 2, 3, 4, 5, and set B is equal to, these are the set of numbers 7, 9, 11, 13, and the function f is given as f is equal to within second bracket. This is in terms of ordered pair 2, 7, 3, 9, 4, 11, and 5, 13. You have to show that f is invertible. In order to show that f is invertible, you have to show that the function f is 1, 1 on 2. then only we can write f is invertible, and hence you have to find out f inverse. Okay, so let us write down the given function out here. That is, given function is f is equal to, within second bracket, this is 2 comma 7, this is 3 comma 9, and this is 4 comma 11 and 5 comma 13, right? So now in this case, in order to prove f is invertible, you have to prove that f is 1 1 on 2. So for this 1 1 on 2, let us write down the domain and range of f. So what is domain of f? So domain of f is equal to, you know what is the domain of f? This first number indicates domain, that is 2 comma 3 comma 4 comma 5. This is your domain of f, that is set A, 2 comma 3 comma 4 comma 5. Then what is range of f? So what is range of f is equal to, that is your 7 comma 9 comma 11 comma 13. That is your range of f. Range of f is the set B in this case. So now here distinct element in the set A has distinct images in the set B. So this is 1 1. Okay, so therefore distinct elements in the set A has distinct images in set B. Is that clear? So here we see that distinct elements in the set A has distinct images in set B. That is, 2 is related with 7, 3 is related with 9, 4 is related with 11, and 5 is related with 13. That is, distinct elements in the set A has distinct images in set B. That is the definition of 1 1, isn't it? Therefore the function f is 1 1. Therefore the function f is 1 1. Okay, so here now for onto here we see that range of f is equal to 7 comma 9 comma 11 comma 13, and here codomain B is equal to 7 comma 9 comma 11 comma 13. That is range of f, that is range of the function f is equal to B. Range of f is equal to B. That is, every element in the set B has distinct pre-images in the set A. So this is onto. Okay, so here range of function f is equal to codomain B. Codomain B. That is, every distinct elements in the set B, every distinct elements in the set B has distinct pre-images. Every distinct element in the set B has distinct pre-image in the set A. That means, therefore the function f is onto. Therefore the function f is onto. Is that clear? So therefore the function f is 1 1 onto. Therefore the function f is 1 1 onto. Therefore the function f is 1 1 onto. So I think you have understood it. So hence f is invertible. So you can write here, since we have proved that f is 1 1 onto, so hence f is invertible. Hence f is invertible. Hence f is invertible. Now we have to find out f inverse. Okay, So now from this given function, we can write down that f of 2 is equal to 7, right? F of 3 is equal to 9. Next, f of 4 is equal to 11. And f of 5 is equal to what? It is 13. Is that clear? Now we have to find out f inverse. That is f inverse 7 is equal to 2. F inverse variance. That is f inverse 7 is equal to f inverse 9 is equal to 3. F inverse 11 is equal to 4. And here f inverse 13 is equal to 5. Is that clear? So now here you have to find out f inverse. So therefore, what is f inverse is equal to now? F inverse is equal to 7 comma 2. This will be 7 comma 2. Next 9 comma 3. Next 11 comma 4. Next it is 13 comma 5. So this is the answer for the function f inverse. So f inverse is equal to 2 7 को के हुन्छ 7 2, 3 9 को के हुन्छ 9 3, 4 11 को हुन्छ 11 4, and 5 13 को हुन्छ 13 5. So this is the function f inverse. So I think you have understood it. So now we'll do the next question. So now we'll do this question, that is question number 7. Let this R plus be the set of all positive real numbers. Let R plus be the set of all positive real numbers. You have to show that the function f such that R plus, here the domain is all positive real numbers. This R plus, first R plus means this is the domain R plus. That is, the domain is all positive values of x. Okay. To minus 5 to infinity. That is, in this case, minus 5 to infinity. Minus 5 is included out here. Minus 5, minus 4, minus 3, minus 5. It should be greater than minus 5. It may be minus 4, minus 3. There is decimal fractions also. And it goes up to infinity, plus infinity. Okay. Such that f of x is equal to 9x square plus 6x minus 5 is invertible. You have to show that this function of x is invertible, and hence you have to find out f inverse. Okay. So here given is, let us prove that this function f of x is invertible. In order to prove that this f of x is invertible, you have to show that this function is 1 1 on 2. Okay. So here given is f such that this first R plus means domain is all positive. That is, x belongs to this domain R plus. X are all positive, right? So 2 minus 5 up to infinity. That means minus 5 is also included here. It is more than minus 5. All the real numbers, this minus 5 up to infinity means all the real numbers which is greater than or equal to minus 5. It goes up to plus infinity. Okay. Defined by, it is defined by what? F of x is equal to 9x square plus 6x minus 5. So I think you have understood it. Okay. Now you know that for x1 comma x2 belongs to R positive. x1 comma x2 belongs to all positive real numbers. So we have f of x1 is equal to f of x2, right? Which implies that, so first of all, you prove that f is 1 1. In order to prove f is 1 1 function, you have to prove that if f of x1 is equal to f of x2, then x1 is equal to x2. Okay. So what is f of x1? Instead of x, you have to put x1. So it is 9x1 square plus 6x1 minus 5 is equal to 9x2 square. Now instead of x, you have to write x2 plus 6x2, then it is minus 5. Okay, so here minus 5 gets cancels, which implies that 9x1 square minus 9x2 square plus 6x1 minus 6x2, which is equal to 0. Is that clear? So which implies that what is common here? 9x1 square minus x2 square plus 6 is common out here. So within bracket we have x1 minus x2, which is equal to 0. Right? So which implies that next 9 into, you know that this is a square minus b square, a plus b into a minus b. Sorry, this is x2. This is a square minus b square, right? A plus b into a minus b. So x1 plus x2 into x1 minus x2 plus 6 into x1 minus x2, which is equal to 0. Okay, so which implies that what is common here? x1 minus x2. So within second bracket 9 into x1 plus x2, then it is plus 6, which is equal to 0. But since x1 and x2 are both positive real numbers, so this expression not equal to 0. Since x1 comma x2 belong to the set of positive real numbers, therefore 9 into x1 plus x2 plus 6, this is not equal to 0. Okay, so which implies that x1 minus x2 is equal to 0, which implies that x1 is equal to x2. So I think you have understood it. X1 is equal to x2. Okay, so now we shows that f is 1 1. So therefore the function f is 1 1. Therefore the function f is 1 1. So now let's prove that this function f is onto. So let us prove that this function f is onto now. So let y belongs to this minus 5, let y belongs to this range, that is minus 5 up to plus infinity. Okay, so now let y is equal to f of x is equal to 9x square plus 6x minus 5, right? So which implies that y is equal to 9x square plus 6x minus 5. Now let us express x in terms of y. Okay, so which implies that, so y is equal to, now we can write it within whole square, that is a square plus 2ab plus b whole square, right? Is that clear? So we are expressing this 9x square plus 6x in terms of a square plus 2ab plus b square in order to get the value for x, right? This is 9x square, that is 3x. This is also the place for x, the place for a, that is 3x. Since this is 6x only, so 2 3s are 6x, into 1 should be there. By which number will you multiply here to get 6x? 1, isn't it? So it is 1. So we are getting 9x square, it's correct. 2 3s are 6x, into 1 is 6x, that is also correct. But here it is 1, but there is minus 5. So what will write here? Minus 6. So which implies that y is equal to, this is your 3x, this is plus 1 whole square minus 6, which implies that 3x plus 1 whole square is equal to y plus 6, right? Which implies that 3x plus 1 is equal to plus minus root over y plus 6. I think you have understood it. Okay, next But in this case, if you put minus sign here, plus 1 is taken to the right hand side. Suppose plus 1 is taken to the right hand side, you will get 3x is equal to plus minus root over y plus 6. This is minus 1. So if you take negative sign here, x will be negative. But in the question it is given that x belongs to the set of positive real numbers. X should be positive. But x belongs to R positive. So you have to discard this minus sign. If you put minus sign here, this will be negative. X will be negative, right? So in order to have positive x, so let us discard this negative sign. So you should take only positive sign. So 3x is equal to root over y plus 6 minus 1, or what is x is equal to? This is 1/3 within bracket root over y plus 6 minus 1. So I think you have understood it. Okay. So next what will you do here now? Since we have expressed x in terms of y, now if this y belongs to this set, that is minus 5 up to infinity, this will be a defined quantity, right? This will be a defined quantity. So here so therefore for each y belongs to this number or this set, minus 5 comma infinity, there exists for each y belongs to this codomain, that is minus 5 comma infinity, first bracket is closed, there exists x belongs to R positive such that f of x is equal to y. There exists x belongs to R positive such that f of x is equal to y. So I think you have understood it. Okay. So now therefore f of within bracket, what is x here? What is x in this case? Here x is 1/3 within bracket root over y plus 6 minus 1, which is equal to, so now instead of x you have to put this number, right? So 9 into within second bracket 1/3 within first bracket, let us put the value for x there, root over y plus 6 minus 1 whole square, okay, plus 6 into again within bracket, 6 into within bracket, what is the value for x here? It is 1/3, right? And within bracket we have root over y plus 6 minus 1, right? We are putting the value for x. Wherever there is x, we are putting 1/3 within bracket root over y plus 6 minus 1, right? Then you have to write down minus 5. Second bracket is closed. Okay, let us simplify it now. And you should get y. So you should get y out here, right? So which is equal to, now in this case, this second bracket is closed, right? I think you have understood it. So I'll write it here. So therefore f of within bracket 1/3, right, within bracket root over y plus 6 and then minus 1. This is the value for x. So on the right hand side we have 9 within second bracket, what is x? Whole square, 1/3 within bracket root over y plus 6 minus 1. Okay, so here second bracket is closed, whole square. So now I think you have understood it. Don't write this one. So f of, what is y here? Here in this case y is here in this case x is 1/3 within bracket root over y plus 6 minus 1, that is the value for x. So हामीले के गर्यौं, यो x को जग्गामा चाहिँ यो लेख्दै छौं. So what is 9 into x whole square? This whole square. Okay. Then next, plus 6. What is x now? So now what is x now? It is into 1/3 and within bracket root over y plus 6 minus 1. Okay. Then what do we write? Minus 5. So now let's simplify it. So which is equal to 9 into what is 1/3 whole square? That is also 1/9. Right? So within second bracket, a minus b whole square. What is a whole square? Root over y plus 6 whole square. That is your y plus 6. That is your y plus 6. Right? Then minus twice ab, 2 root over y plus 6. Then plus b whole square. That is your 1. Second bracket is closed. So I think you have understood it. This is a square minus 2ab plus b whole square. Okay. So next, what will you do now? Plus, this is 3 2s are 6. Now multiply by 2 here. 2 root over y plus 6 minus 2 minus 5. Minus 2 minus 5. So I think you have understood it. Okay. So next, what will you do here now? So this 9 gets cancels, which is equal to, this is your y plus 6 minus 2 root over y plus 6 plus 1, right? Plus 2 root over y plus 6, then this is minus 7. So here you can cancel this minus plus, 6 plus 1 is 7, 7 gets cancels, which is equal to y. So which implies f of x is equal to y. Is that clear? So therefore the function f is onto. Therefore the function f is what? Onto. Therefore the function f is onto. So I think you have understood it. So therefore the function f is, therefore the function f is 1 1 onto. Therefore the function f is 1 1 onto. Hence f is invertible. Hence the function f is what? It is invertible. Hence the function f is invertible. So I think you have understood it. So now let us find out f inverse now. So therefore just now we got x is equal to, what was x is equal to? X was 1/3 within bracket root over y plus 6 minus 1. Again निकालेको हैन हामीले यो. That is we had expressed x in terms of y. That is x is equal to 1/3 within bracket root over y plus 6 minus 1. You can check it. So instead of x, what can you write? That is f inverse y is equal to 1/3 within bracket root over y plus 6 minus 1. So this is the final answer for f inverse. So I think you have understood it. So you can copy it. Now I'll give you the homework. Okay. So now these are your homework. You can do it at home. So your homework will be question number 3 is that is from exercise 2C, page number RF48 from the book Senior Secondary School Mathematics by R.S. Agarwal. Okay. So your homework is question number 3. Let f function f such that real to real number defined by f of x is equal to half within bracket 3x plus 1. Okay. So in this case you have to show that f is invertible. So in order to show that f is invertible, you have to prove that the function f is 1 1 onto. So you know how to prove the function f as 1 1 onto. Okay. Then you can write, if you can prove that f is 1 1 onto, then you can write down that f is invertible, and hence you can find out f inverse also. Okay. So this is your homework. Next exercise 2D. Next one is exercise 2D. Page number relation and function chapter, that is 49, page number 49, from the same book. From the same book, that is Senior Secondary School Mathematics for Class 12 by R.S. Agarwal. So this is exercise 2D. Okay, so we can do this as homework. That is question number 1 is prove that the function f such that real to real number defined by f of x equal to x is 1 1 and onto. You have to prove this as bijective function. 1 1 and onto means bijective function. Sometimes you may be given the question like this also. Prove that the function f such that real to real number defined by f of x is equal to x is bijective. Bijective function means 1 1 and onto. Okay. So number 2 is prove that the function f such that natural number to natural number. This is the set of natural number. F of x equal to 3x is 1 1 and into, not onto. Okay. And number 3, let R0 be the set of all non-zero real numbers. 0 हुनु भएन यहाँ. ठीक छ? All non-zero real number means it should not be 0. Okay. Then so that the function f such that R0 to R0 defined as f of x is equal to 1 by x is 1 1 and onto. So we can do it. So question number 4 is let the function f such that real to real number defined as f of x is equal to x minus 7 by 4 be an invertible function. Here's an invertible function. So you don't have to show that this is 1 1 and onto. Just find out inverse. So you have to find out f inverse. Y suppose x value in terms of y you can get the value for f inverse. Okay. So next question number 5 is let f such that real to real number defined as f of x equal to 10x plus 3. Find f inverse. In this case also you don't have to show that this function f is invertible. Check गरिरहनु पर्दैन यो f is 1 1 onto भनेर प्रुभ गरिरहनु पर्दैन. Just find out f inverse by using let y is equal to f of x is equal to 10x plus 3, express x in terms of y, then you can easily get f inverse. So I think you have understood it. Okay. So these are your homework. त आज हामीले जति पनि प्रब्लम्सहरु गरेका छौं त्यो सबै घरमा रिभिजन गर्नु अनि यो होमवर्क पनि गर्नु. सो अझै छ मैले तिमीलाई क्वेशन दिनुपर्ने त्यो होमवर्क. सो यो चाहिँ म नेक्स्ट क्लासमा म तिमीलाई होमवर्क दिनेछु. ठीक छ? So this much is for today.